This is my larynx model. There's several components that make up the larynx. However, I'm going to say 15 of them today. First, we're going to start with the trachea, which is in light blue. It connects the pharynx and the larynx to the lungs. Next are the tracheal rings, which are in orange. The rings support the trachea and allows the trachea to move or flex. The cricoid cartilage, which is in yellow right here, it helps open and close the airway and also helps with speech production. Next is the epiglottis, which is on the inside right here. It prevents food from entering the windpipe and also helps with swallowing. Next is the thyroid cartilage right here. It helps protect and support the vocal folds. Next is the hyoid bone, which is in orange up here. It's an important muscle because it attaches and supports the larynx and the tongue. Next is the arytenoid cartilages, which are right here. They're pyramid shaped. They serve as the posterior attachment for the false vocal folds right here. And on top of these arytenoid cartilages are the corniculate cartilages, and they serve no purpose for voice production. Next is the posterior cricoarytenoid muscles. Sorry, I have a hard time saying that. And they abduct the vocal folds and also rotate the arytenoid cartilages laterally. And next after that is in blue right here is the lateral cricoarytenoid muscles, and they're major adductors of the vocal folds, and they regulate tone and volume of speech. Next in orange right here is the transverse arytenoid, and the transverse arytenoid adducts the vocal folds and plays an important role in the process of phonation. Next is right here, this crisscross right here in blue. That's the oblique arytenoid. It helps with adduction and prevents liquids or foods from going into the lower respiratory tract. And then next is this light blue right here. It's the thyroarytenoid muscles. It's such tricky words. Forms the body of the vocal folds, and it shortens the vocal folds upon contraction. Next is in pink right here is the cricothyroid. It creates tension and elongation of the vocal cords and also creates a higher pitch when they're elongated, when the vocal folds are elongated. And then inside is the vocalis muscle. It tenses and thickens the vocal cords. So the process of phonation is also known as the amyoelastic theory of voice production. In order for a phonation to happen, you have to have three components, which are respiration, phonation, and articulation. So the process of phonation starts when air is brought into the lungs, and then the air that is brought into the lungs is pushed up into the glottis and then pushed up underneath your vocal folds. And when air is pushed up into the glottis and then pushed up underneath your vocal folds, it causes pressure to drop in the larynx. And this makes the vocal folds vibrate to produce sound, which is also known as phonation. This sound is then filtered through the vocal tract, which is also known as articulators, things like that, to produce a specific phoneme or word. And then the process of pitch change when the vocal folds are lengthened. The cricothyroid muscle aids the vocal folds to change in length due to the decrease in mass, which in turn creates a faster vibratory rate, and that's how pitch changes.